we are discussing the electron scattering, and there are two diagrams which contributes to the process in the lowest order. These two diagrams are given by the following: P2 going to P2 prime, P1 going to P1 prime, and there is a photon of momentum P1 minus P1 prime. The other diagram is P2 going to P1 prime, P1 going to P2 prime, and the virtual photon carries a momentum P1 minus P2 prime. We can easily write down the Feynman amplitude for the process, and as we have seen in the last lecture, the Feynman amplitude is minus I e square u bar r prime P1 prime gamma nu u r P1 u bar s prime P2 prime gamma nu u s P2 divided by P1 minus P1 prime square minus u bar s prime P2 gamma rho u r P1 u bar r prime P1 prime gamma rho u s P2 divided by P1 minus P2 prime whole square. And what comes in the differential scattering cross section is mod m square average, which is 1/4 of sum over r s r prime s prime mod m square. So, the mod m square contains 4 terms. One of them is mod square of this, the other one is mod square of this, and there are the cross terms. So, we have evaluated the mod square of this in this last lecture, and we will now evaluate one of the cross terms. The other two terms will be obtained by exchanging P1 prime with P2 prime. So, the cross term, one of the cross terms here is just given by the following quantity, which is so the cross term is just minus 1/4 and then 1 over P1 minus P1 prime whole square, P1 minus P2 prime whole square, then conjugate of this quantity u bar r prime P1 prime gamma nu u r P1 u bar s prime P2 prime gamma nu u s P2 conjugate of this times this quantity here, which is u bar s prime P2 gamma rho u r P1 u bar r prime P1 prime gamma rho u s P2, where r s r prime s prime are summed over all possible values. So again you can write these quantities in terms of the components, and then you use the identity u bar u or u bar is p slash plus m over 2m repeatedly. Okay. Then it is straightforward to see that the sum here will be reduced to a trace, and this will be given by trace of gamma nu P1 slash plus m divided by 2m, gamma rho P2 prime slash plus m divided by 2m, gamma nu P2 slash plus m divided by 2m, gamma rho P1 prime slash plus m divided by 2m. So, I leave it as a homework for you to evaluate this and show that this quantity is equal to trace of the following. Notice that this contains 1, 2, 3, 4, there are 8 gamma matrices. So, you need to evaluate this trace. However, there will be considerable simplification if you note that this gamma nu here is contracted with this gamma nu here, this index nu is contracted with this index nu, and this can make a lots of simplification. So, our goal is to evaluate this trace, or what we need to do is we need to evaluate trace of gamma nu P1 slash plus m, gamma rho P2 prime slash plus m, gamma nu P2 slash plus m, gamma rho P1 prime slash plus m. This is what we need to evaluate, and we will use various identities involving the gamma matrices to evaluate this trace. So, for this note that so first of all we can consider this. What I will do is that I will show gamma nu P1 slash plus m, gamma rho P2 prime slash plus m, gamma nu. This quantity is equal to minus 2 P2 prime slash gamma rho P1 slash plus 4 m P2 prime rho plus P1 rho minus twice m square gamma rho. So, I will show this quantity is equal to this, and then I will substitute it here, and then it will be quite simple to evaluate the trace. So, let us first consider this and then prove this identity. To prove this, we will note several identities. One of them is, so this involves terms which are like gamma nu, gamma mu, gamma rho, gamma sigma, gamma nu. This also involves gamma nu, gamma mu, gamma rho, gamma nu, and also term like gamma nu, gamma rho, gamma nu. The coefficient of m square is just this, and the term which is linear in m contains something like this, whereas the remaining term contains some expression like this. So, all these things we can simplify greatly. So, let us consider the last one first. Gamma nu, gamma rho, gamma nu is nothing but gamma nu times, I will use the identity gamma rho, gamma nu is twice eta rho nu minus gamma nu, gamma rho. Okay. Now, the first quantity is simply twice gamma rho and minus gamma nu, gamma nu, gamma rho. What is gamma nu, gamma nu? It is 4. Yeah. Yeah, it is 4. So, this is 4, 2 minus 4, which is minus 2 gamma rho. So, this quantity here is nothing but minus 2 gamma rho. Now, we will consider this one. Okay. So, what is this? This is gamma nu, gamma mu, gamma rho, gamma nu. Now, what I will do is that I will flip the gamma matrices here as well as here. So, the first two gamma matrices can be written as twice delta nu mu minus gamma mu gamma nu, and the second last two terms are twice eta rho nu minus gamma nu gamma rho. Now, I will expand this. The first term is simply 4 times delta mu nu eta rho nu, which is eta mu rho. Then this term here will give minus 2 gamma mu gamma rho, and this multiplied with this again will give me mu minus twice gamma mu gamma rho. Finally, the last term is gamma mu gamma nu gamma nu gamma rho. This is 4. So, this will cancel with these two terms. So, what is left is 4 eta mu rho. So, this quantity here is nothing but 4 eta mu rho. Now, we can easily evaluate the first term here. So, what is the first term? You consider gamma nu, gamma mu, gamma rho, gamma sigma, gamma nu. Now, you flip the last two gamma matrices, that will give you gamma nu, gamma mu, gamma rho times twice eta nu sigma minus gamma nu gamma sigma. All right. Now, what is the first term? This eta nu sigma can be contracted with this to give twice gamma sigma gamma mu gamma rho, the first term, and the second term is minus gamma nu gamma mu gamma rho gamma nu gamma sigma. Okay. Now, what you can do? You can use this identity here, that will give me this quantity is simply 4 times eta mu rho. This is mu rho right here. So, minus 4 eta mu rho gamma sigma. So, twice gamma sigma, if you take common 2 gamma sigma, then what is left is gamma mu gamma rho minus twice eta mu rho. What is this quantity? Minus gamma rho gamma mu. So, what you get here is minus 2 gamma sigma gamma rho gamma mu. So, this order here is flipped and you get a minus 2 factor. So, we will use these 3 identities repeatedly, and then so let us consider the left hand side here. gamma nu p1 slash plus m gamma rho p2 prime slash plus m gamma nu. I will expand this. So, this will give me gamma nu p1 slash gamma rho p2 prime slash gamma nu, that is the first term. The second term plus gamma plus m times gamma nu gamma rho p2 prime slash plus p1 slash gamma rho gamma nu, and finally plus m square gamma nu gamma rho gamma nu. Okay. So, we know this identity. So, the first identity will make this very simple. So, this will simply tell me that this is nothing but minus 2 p2 prime slash gamma rho p1 slash, and this term here will tell me that this is m times gamma 4m p2 rho prime plus p1 rho, and this one minus 2 m square gamma rho. This is obvious. Now, if I just expand, the proof is obvious once I use these three identities. So, now what I will do is that I will insert this here and I will expand all these terms to evaluate the trace. So, what we need to do is we need to look into trace of gamma nu p1 slash plus m gamma rho p2 prime slash plus m gamma nu, and then p2 slash plus m gamma rho p1 prime slash plus m. What I will do is that for this I will substitute this one, and then here I will expand this, and that will give me trace of minus 2 p2 prime slash gamma rho p1 slash plus 4m p2 rho prime plus p1 rho minus twice m square gamma rho times p2 slash gamma rho p1 prime slash, and m p2 slash gamma rho plus gamma rho p1 prime slash, and then there is m square gamma rho. This is what I will get by straightforward multiplication. Now, what I will do is that I will multiply this term with this term, and then I will keep in mind that trace of odd number of gamma matrices vanishes. So, if I do that, what I will get, this one. So, we will do that, and whenever we have odd number of gamma matrices, we will leave that out. So, what I get here is trace of minus 2 p2 prime slash gamma rho p1 slash p2 slash gamma rho p1 prime slash, then minus so this contains 3 gamma matrices, this contains 2 gamma matrices. So, this vanishes. Finally, minus 2 m square p 2 prime slash gamma rho p 1 slash gamma rho, and then I will consider this term, this multiplied by this. When I take the trace, it will be 0 because there are 3 gamma matrices, there is no gamma matrix here, whereas this with this will survive. So, what I have is 4 m square p 2 rho prime plus p 1 rho, then p 2 slash gamma rho plus gamma rho p 1 prime slash. Okay. Then this multiplied with this will give me 0. Now, this with this will survive. So, that will give me minus twice m square gamma rho p 2 slash gamma rho p 1 prime slash, this with this will 0 will give me 0. Finally, this multiplied with this will give me minus twice m fourth gamma rho, but gamma rho is 4. So, this will give me minus 8 m fourth times the identity matrix. This is what I got. Now, again I will repeatedly use these identities. In the first one, so okay, so the last 2 identities are useful now. Look at this one is gamma rho p 1 slash p 2 slash gamma rho. What will this be? 4 p 1 dot p 2. So, 4 p 1 dot p 2, and here this one is minus 2 gamma rho okay. So, this is minus 2 p 1 slash minus 2 p 1 slash, and here of course, this we have to evaluate, and here minus 2 p 2 slash, right. So, now we will use, when we substitute that, it will take a simple form. So, what I get is trace of minus 8 p 1 dot p 2 p 2 prime slash p 1 prime slash plus 4 m square p 2 prime slash p 1 slash plus 4 m square p 2 prime rho plus p 1 rho p 2 slash gamma rho plus gamma rho p 1 prime slash, then plus 4 m square p 2 slash p 1 prime slash minus 8 m fourth times the identity. This is the trace. that we need to evaluate, but now it is very easy to evaluate the trace. First term, what is trace of this? So, this is 4 p1 prime dot p2 prime. So, this is minus 32 p1 dot p2 p1 prime dot p2 prime. This one 16 m square p1 dot p2 prime, and here you can see that this will give me 4. So, this is 16 m square p1 plus p2 prime dot p1 prime plus p2, right, and here this is 16 m square p1 prime dot p2 minus 32 m fourth. Is this right? So, now what we will use, the energy momentum conservation relation repeatedly, that is p1 plus p2 is p1 prime plus p2 prime. That will tell me that p1 prime dot p2 prime is p1 dot p2. So, this is minus 32 p1 dot p2 whole square, and here I will leave it as it is. Okay, I can add this and this, because p1 dot p2 prime is p1 prime dot p2. So, this is 32 m square p1 dot p2 prime, and then 16 m square I can write it as p1 dot p1 prime plus p1 dot p2 plus p2 prime dot p1 prime plus p2 prime dot p2 and minus 32 m fourth. Now, look at this, you can consider one of the terms here, and then you can combine it with, there is a p1 dot p2 prime, there is p1 dot p1 prime. Okay. So, that this will give me half of this, with this term will give me 16 m square p1 dot p1 prime plus p2 prime. Okay. And then again the remaining term here p1 dot p2 prime, I will combine it with this one last term. Okay. Then what I will get is p2 prime dot p1 plus p2. Now, you can see why I wanted to combine it in this fashion, because here I can use the energy momentum conservation relation, and then I can write it as p1 plus p2. Similarly, here I can write as p1 prime plus p2 prime. So, this takes care of this term and then these two terms. What is left is these two here. So, they are equal. So, this is twice p1 dot p2. That is what I get when I add this term with this term. So, this is equal to minus 32 p1 dot p2 square plus this minus 32 m fourth. That is what I get. Now, as I said, I will use the energy momentum conservation. Then this term here is p1 dot p1 plus p2, and here this term is p2 prime dot p1 prime plus p2 prime, and here 2 p1 dot p2. Now, what is this? This is p1 square, which is m square, plus P1 dot P2. Here I will get P2 prime dot P1 prime, which is again P1 dot P2 and P2 prime square, which is m square. So, plus 2 P1 dot P2. So, this is simply twice m square plus 4 P1 dot P2. Okay. Now, this twice m square is multiplied by 16 m square. Okay. So, that will give me plus 32 m fourth, that will cancel with this minus 32 m fourth, and so at the end of the day what I get is minus 32 P1 dot P2 square and then plus 16 into 4, which is 64 P1 dot P2. There is nothing else left. So, this is what I get. So what I did is I evaluated this trace here, and then at the end of the day this is simply equal to minus 32 into P1 dot P2 square minus twice P1 dot P2. This is what I get for this trace. So, there is an m square here, 2 m square, thank you. This is 64 P1 dot P2 m square. So, what we will do is that we will now substitute all these things in the expression for m square average. Remember, when we computed m square average, there was a factor of 1 over 4 because of the average over spins of incoming electron, and then we had p slash plus m over 2m, those terms were there, there are 4 such things. So, that will give me 1 over 2m to the power 4th, and finally we had this trace. So, one of the diagrams had the photon propagator, which is P1 prime minus P1 square in the Feynman amplitude, and when I take mode m square, it is square of this, and I have the trace, which is trace of gamma nu P1 slash plus m gamma rho P1 prime slash plus m times trace of gamma nu P2 slash plus m gamma rho P2 prime slash plus m. This is the first term. The second term, which we have evaluated today, is minus 1 over P1 prime minus P1 square for the photon propagator from the first diagram, P2 prime minus P1 square for the photon propagator in the second diagram, and then this trace here, trace of gamma nu P1 slash plus m gamma rho P2 prime slash plus m gamma nu P2 slash plus m gamma rho P1 prime slash plus m. These are the first two terms, and then the remaining two terms are obtained from these two by exchanging P1 prime with P2 prime. So, this is the expression for mode m square average. What I will do is that I will substitute here for the value of this and this. This was evaluated in the last lecture, and this we have seen is equal to minus 32 P1 dot P2 square minus 2 m square P1 dot P2. So, we will directly substitute these things here. If you recall, this quantity here is nothing but 32 times some factor. So, there is an overall factor of 32 here, which will cancel the 8 into 4 here. So, what will be left is 1 over 2 m fourth. Okay. So 2 to the power 3 and 4, that will cancel the 32, and there will be a 2 left and m fourth. So, that will give me mode m square bar is 1 over twice m fourth, then this here 1 over P1 prime minus P1 whole fourth times, if we substitute 1 over 32 times this, then what we get is P1 dot P2 square plus P1 dot P2 prime square plus 2 m square P1 dot P2 prime minus P1 . And this term here will give me plus, as you can see, this you can see there is a minus which will give me plus. This 32 we have cancelled it here with 4 into 2 to the power 3. So, this is plus this times this. So, plus 1 over P1 prime minus P1 square P2 prime minus P2 square times P1 dot P2 whole square minus 2 m square P1 dot P2. Okay. These are the first two terms, and then the remaining two terms will be obtained from these two by exchanging P1 prime and P2 prime. So, from the first term I get 1 over P2 prime minus P1 to the power 4th times P1 dot P2 square plus P1 dot P1 prime square and plus 2 m square P1 dot P1 prime minus P1. That is from here, and you can see that this term is invariant under the exchange of P1 prime and P2 prime. So, I will just get a factor of 2. So, we have got this. Now, we will use the fact that we are doing the calculation in the center of mass frame. So, in the center of mass frame, we will evaluate what is the value for P1 dot P2, P1 dot P1 prime and so on, and finally, we will substitute those, and at the end we will substitute this in the expression for the differential scattering cross section. So, let us go to the center of mass frame. You have the incoming electron with momentum P1 and momentum P2, and then the scatter, and then you have outgoing electron with momentum P1 prime, P2 prime. What are the energies of these electrons? Let us consider this P1 plus P2. In the center of mass frame, this is equal to 0. Now, if you consider P1 0, which is just square root of m square minus P1 square, right. Now, because of this, mod P1 is equal to mod P2. So, this is m square minus P2 square, which gives you P2, it is plus P1 square, m square equal to P, yeah. So, this is nothing but P2 0. Okay. So, this simply says that P1 0 is equal to P2 0, which I will denote as E. The total energy is conserved, and you can use the same argument, which will say that P1 0 prime is equal to P2 0 prime. Therefore, this also has to be equal to E. So, this is what is the conclusion that we got. Now, so we have what we need to do is we need to evaluate P1 dot P2, P1 dot P1 prime, P1 dot P2 prime. What I claim is that this is equal to twice E square minus m square. This is equal to E square 1 minus cos theta, where theta is this angle, plus m square cos theta, and this is equal to E square 1 plus cos theta minus m square cos theta. Let us first look at this relation here. P1 dot P2 is nothing but half P1 square plus P2 square minus, P1 plus P2 square minus P1 square minus P2 square, right. But P1 plus P2 square P1 0 plus P2 0 square minus P1 dot P1 plus P2 dot P1 plus P2. But P1 plus P2 is 0 in the center of mass frame, and this is twice E. So, therefore, I got this to be half 4 E square minus 2 m square, which is what is given here. Now, I will evaluate P1 dot P1 prime, and then you can evaluate P1 dot P2 prime in a similar way. So, P1 dot P1 prime is again half P1 plus P1 prime square minus P1 square minus P1 prime square, right. Half. So, the 0th component will give me 4 E square minus P1 plus P1 prime dot P1 plus P1 prime. This is minus twice m square. And what do you get from here? Half 4 E square minus mod P1 square minus mod P1 prime square minus twice P1 dot P1 prime. minus twice m square. What is p1 square, mod p1 square? E square minus m square, and mod p1 prime square is also e square minus m square. So, this will give me half 4 e square minus twice e square minus m square, and what is this p1 dot p1 prime? Why minus cos theta? This is the direction of p1, right? It's cos theta. Okay. So, minus twice e square minus m square cos theta, and then minus 2 m square. All right. So, as you can see, this m square here, it will cancel with this 2 m square, and what you have is half times this will give me twice e square minus twice e square minus m square cos theta. This factor of 2 will cancel here. So, what you are left is e square into 1 minus cos theta plus m square cos theta. Okay. So, you can similarly evaluate p1 dot p2 prime, and then you can show that this is equal to this. Finally, you at the end you substitute all these results here, because this involves all these squares which are m square and then p1 dot p1 prime or p1 dot p2 prime, nothing else. So, you substitute these expressions for p1 dot p2, p1 dot p1 prime, p1 dot p2 prime in mod m square, and then you simplify. It is very straightforward. You will see that the differential scattering cross section at the end of the day will look like d sigma over d omega is equal to alpha square times twice e square minus m square. Now, you can see the origin of all these terms, 4 e square minus m square whole square times 4 over sin 4 theta minus 3 over sin square theta plus e square minus m square whole square m square whole square 1 plus 4 over sin square theta. Okay. So, this is what is the expression for the differential scattering cross section for electron scattering. Okay.